be equal to x minus iy whole square, x square minus y square minus 2i xy. Here I have calculated mentally, that is equal to tan inverse x1 y2 plus x2 y1 by x1 x2 minus y1 y2. Welcome to btosacademy. Welcome to my maths class. Actually, today I shall continue the topic complex number. Already properties related to modulus have been discussed. Now, few more properties. Serially, I am discussing. First of all, if z be a complex number, then modulus of the square of the complex number, modulus of z square will be equal to square of the modulus of z, that is mod z square, that will be equal to square of the modulus of the complex conjugate of z, and that will be equal to modulus of square of the complex conjugate of z. Next, and that will also be equal to z bar. Then properties related to amplitude argument. Amplitude or argument of the product of the complex number z1 and z2, that is argument of z1 into z2 is equal to argument of z1 plus argument of z2 plus say m. Then number 3, argument of the quotient is equal to argument of z1 minus argument of z2 plus m. In both cases, m will be equal to 0 plus minus 2 pi plus minus 2 pi. Let me clarify why this is used. Actually, amplitude or argument, according to the definition, principal value of the argument, if theta be the argument or amplitude of z, then interval for already it is discussed. If theta be the amplitude, rather principal value of the amplitude, then the interval in which theta will lie minus pi to pi, including pi. Now, in some cases, argument of the products or quotient of two complex number may not satisfy this one. That is why, to satisfy this condition, we have to add m or m, and values of m will be 0 or plus minus 12. Next property, related to conjugate, z1 plus z2 conjugate of the sum of two complex numbers will be equal to conjugate of sum of two complex numbers z1 z2 is equal to sum of their conjugates, that is z1 conjugate plus z2 conjugate. Also for difference, conjugate of z1 minus z2 is equal to z1 conjugate minus z2 conjugate. We apply the term also bar. Number 5, complex conjugate of product of two complex numbers is equal to product of their complex conjugates, and conjugate of the quotient of the complex numbers z1 and z2 is equal to the quotient of their conjugates. These are the remaining properties of complex numbers. Now I shall prove few of these. Not all students are advised to prove yourself. Those who are interested in mathematics. Proof. Let z equal to x plus iy. Therefore, conjugate will be x minus iy. Therefore, z square x plus iy whole square, x square plus 2ixy plus I square y square, that is equal to x square minus y square plus 2ixy, and z bar square will be equal to x minus iy whole square, x square minus y square minus 2ixy. Here I have calculated mentally. Finally, the result will be this. Now we calculate, first of all, modulus of z square, that is right, modulus of z square is equal to if a plus ib be a complex number, then its modulus is under square root symbol a square plus b square. Form a minus b whole square plus 4ab. Already you have learned that that is equal to square root of x square plus y square whole square, that is equal to x square plus y square. Then square of the modulus of z, that will be equal to modulus of z is root over x square plus y square. Therefore, this one. Then modulus of z bar square then modulus of square of z bar, that is equal to square root of x square minus y square whole square plus 4x square y square, and that will be equal to x square plus y square. As under square root symbol, the expression is of the form a minus b whole square plus 4ab, that is equal to a plus b whole square. That is why this one. Then another one is z bar, that is equal to x plus iy into x minus iy. That is on a multiplication x square minus I square y square, that is equal to thus we see all values, all 5 values equal. Therefore, this property is proved. Next, I prove one property related to argument. Proof is very easy. Then number 2, argument of this one. We take two complex numbers as therefore first we multiply. I am multiplying here, keeping in mind I will write first real part, then imaginary part. Then if we multiply these two, that will give minus y1 y2 plus I x1 y2 plus x2 y1. Now amplitude z1 is tan inverse y1 by x1. Amplitude z2 is tan inverse y2 by x2. We are considering principal value. Also, for understanding purpose, we are taking x1, y1, x2, y2, etc. as positive numbers. Then amplitude z1 into z2, that will be equal to amplitude x1 x2 minus y1 y2 plus I x1 y2 plus x2 y1, that is equal to tan inverse x1 y2 plus x2 y1 by x1 x2 minus y1 y2. Now I can divide both numerator and denominator by x1 x2. x1 y2 plus x2 y1 divided by x1 x2, x1 x2 minus y1 y2 divided by x1 x2. Actually, formula related to inverse is not included in class 11 syllabus. That is equal to tan inverse y2 by x2 plus y1 by x1 divided by 1 minus y1 by x1 into y2 by x2. That is according to the formula, tan inverse A plus tan inverse B is equal to tan inverse numerator A plus B divided by 1 minus AB. This formula you will get in class 12. Just I am applying that here directly. That is equal to tan inverse y1 by x1 plus tan inverse y2 by x2. and already we have got these are the amplitudes of Z1 and Z2. Therefore, finally we get amplitude of Z1 into Z2, that is amplitude of products of two complex numbers is equal to amplitude Z1 plus amplitude Z2. But I have mentioned that for the understanding purpose we have taken x1, y1, x2, y2, etc. as positive, but those are not known. Those may be positive as well as negative, and according to the definition of principal value of the amplitude will fall in any of the four quadrants. If it falls above the y-axis, then we have to adjust in some cases some of these amplitudes that may be greater than pi, also that may be larger than pi, or sometimes less than 2 pi. For that adjustment we have to add a number, say m, and m will be, already I have mentioned, 0 or plus minus 2 pi. Actually after calculation we will find the position of the complex number. Accordingly you will write the exact value. Thus this is the proof for the second one.